Hello, this is another video, and today I'm going to talk about the the second part of the P-delta. In the previous video I was talking about the main concept and the rationale of P-delta effects in general, and in this time I'm going to talk about the part 2, which is going to be an application of the P-delta effect, and we're going to use one example for checking of one individual story in a multi-level story. So now let's go to the example directly and see how it works for us. So this P-delta effects, as I have mentioned before, it is related to the section 12.8.7 in the code. And let's look to the problem statement and only a few or a small kind of introduction for the P-delta. In high-rise building design, important secondary moments and additional story drifts can be developed in the lateral force resisting system by P-delta effects. As we said, whenever that we have especially for the high-rise, okay, we are having, like, if there is a kind of lateral displacement that would take place due to the earthquake, the gravity loads are going to make a great deal of effect if we have a very high structure like this, and if the loads are high, P, where the gravity loads are high. This provides a kind, if we have the delta here between the two, this P delta, we call it P delta because there is additional moment that is going to be added to the elements, the beams or girders and columns, and also the drifts that need to be considered in our design. P-delta effects are the results of axial load P in column being moved laterally by horizontal displacement, as I have shown here, thereby causing additional secondary column and girder moments. These are the effects of the P-delta in general. The purpose of this example is to illustrate the procedure that must be used to check the overall stability of the system, of the frame system, for such effects. It's a very good example. It is going to we are going to go through the P-delta effect step by step and with the application and with some real numbers that is going to make sense for us, and it will help and guide you for solving similar problems or similar structures. We have a 15-story building, has a steel special moment frame, so it's 15-story, as you can see here. It is 15-story building, and the seismic design category is D. Response modification factor is 8. CD, the displacement modification factor, 5.5. and the importance factor is 1. And the height of the story, it is 20 feet, as you can see. Okay. At the first story, we are going to check it for the first story. So as I have mentioned before, P-delta is conducted or calculated for single or individual stories. It's not for the entire structure. So if you want to check, you need to check all the stories, for example. Okay, so we are going to check it for the first story because the loads in this case is going to be the highest, right? Even that H is going to be, and H actually is going to be the story height here, but the load is going, what we are going to use here is the total dead load, as we have mentioned before, because if we are going to upper stories here, for example, so in this case, we are going to look to the to the story shear at this level and the gravity load at this column or at the level or the columns of that level. And then we have this is the dead load, we have the live load, this amount, and we have V1, which is the story shear at floor 1, and it equals 2.042 of the total weight of the structure, and it equals to this value, which is 363 kips. Beta, if you remember beta, we were talking about it, which is the capacity ratio, or we can say that the demand to the capacity ratio of the structure, 0.8, it is given for us. Okay, the highest demand to capacity ratio. The height of the story is 20 feet. It is given. Deflection at level X equal to 1, which is the first floor, due to seismic base shear V without P-delta effect. Take care that whenever that we are starting our P-delta effect, we start from the original seismic base shear that we have calculated based on section 12.8, for example. Okay, and then the corresponding elastic delta based on our calculations and based on the code guidelines, it was 0.003 H1, which is 0.72 inches. Okay, these are given information for our structure. Okay, we want to determine the following. We have 5 requirements here. Let's go through one after one. Initial design story drift delta in the first story. Take care of this word, which is initial. Initial means that without any P-delta effect. Design story drift. Take care of the word design. We're not talking about the elastic. Okay, so we're talking about the design now, which is having this uppercase delta, okay, in Greek letters. Okay, and number 2, requirement number 2, it is we want Pdelta criteria for the building. What is the criteria for this building? Which is calculation of theta, and see whether that we are under theta minimum, where that the P-delta is going to be neglected or going to be insignificant, or that we are going to be larger than theta maximum, which means that the entire structure needs to be redesigned because it will experience a kind of instability. If we are in between, which is theta, which is larger than 0.1, for example, in this case, and of course less than theta maximum, and this is the theta minimum, which is the 0.1. If we are larger than the theta minimum, which is 0.1, then we are going to say that we need to include P-delta in our analysis. Okay. And requirement number 3, it is P-delta effects in the first story. We are going to calculate if we found that P-delta need to be included. This means that we need to increase the force or the members, girders, columns, forces, and the drift forces, drift values as well. Okay, so we are going to include them. And number 4, we want to find the final design story drift. So take care, we're talking about the final. Final means that with the inclusion of P-delta, we want the final design story drift and story shear, and the first story, of course. Okay, so we want the design one after inclusion of P-delta. And the last requirement is the story drift compliance in first story. Compliance means that we want to check it against the code limits that is provided for this structure, which is steel special moment resisting frame. Okay, so these are the main requirements of this example, and we are going to solve this problem step by step and showing all the requirements. Okay, now let's go to the first requirement, which is related to initial design story drift delta in the first story. Okay, it is easy actually to find that at the first story we have x equal to 1, the initial design story drift. It is going to, because we are having, this is the bottom of the structure here, the first story, so it is, the bottom is 0. We do not have any kind of deltas here, so delta x minus 1 here equal to delta 0 here, and this is delta x, which equal to delta 1 here, and here this would equal to 0. And now we want to know this delta 1, and delta 1 already given for us. It is given in the information or in the info of this problem. So we have delta 1 equal to 0.72 if you check the information, okay, of the structure. We have it here highlighted, 0.72 inches. Okay, now let's go to obtain the design. Take care, this one, this delta, okay, delta x and delta x minus 1, we need to to have the difference between the two. And this delta, it is without amplification, without taking into consideration the amplified or the amplification due to the inelastic performance of the structure. So it needs to be multiplied by CD, so this delta, so delta, which is the design story drift. We're talking about the design story drift. It should equal to delta 1, that is going to be obtained from elastic analysis, times CD obtained from the tables, and over the importance factor. And this is what we are having here. So this is delta 1. It seems that he is using delta 1 as the designation for the design story. Okay, it is for the inelastic. So now delta 1 equals to delta 1 elastic times CD over I. So this delta 1, 0.72, CD, it is 5.5, the deformation amplification factor given, and the importance factor, as we said, it was 1. So when you calculate, you found that it is 3.96. This is the design story drift. Okay, this is the design story drift for us. Now the structure is going to move laterally a distance here equal to delta, which is going to be 3.96 inches. Okay, this value is termed initial. As we said, this is initial because why? What is the reason for this? Because it is without P delta, because it may need to be increased by incremental factor AD, as we are going to see in requirement number 4 or part number 4 of this example. Anyway, until now we have obtained the initial design story drift delta, and let's go to the next requirement to see what is needed. Okay. The second requirement was the Pdelta criteria for the building. Whenever we say Pdelta criteria, it means that we want to check the stability coefficient, as we have explained it in the previous video in detail. So all the letters here, we already have explained it in detail in the previous video. Just a reminder for you, we have theta, px. So theta is the stability coefficient for story x. It is the ratio between the secondary moment to the primary moment, or we can say it is the ratio between kg and k initial, if you remember this, the geometric stiffness over the initial stiffness. Okay, and px, it is the total design vertical load. The word vertical is important here. On all columns in story x. Note, no factor above 1 is required. Surface loads are used, as I have mentioned in the previous video. No factored load are used for this. It is for surface loads only. And vertical means that live load, dead load, snow load, everything. Okay, it is vertical only, not lateral. Take care of this. Okay, and now for delta, which is this one, it is the initial design story drift as we have obtained it, and story x occurring simultaneously with CD and Vx. That's right, because we use CD here and Vx here. I think that we should put I here, but I, it is 1 here in this case, but it should have been added, because I sometimes may be taken as 1, okay, or more than 1, so it should be added here. So anyway, this is the stability coefficient, okay, which is theta, and it should be having I here. Okay, now we are checking it, because if this value of theta is larger than 10% or 0.1, this means that we need to consider, okay, consider P delta effect. But if it is smaller than 0.1, then P delta effect would be negligible and insignificant, and no need to take it into consideration. Okay, and the next one is Vx, which is the seismic shear force in story x, and then Sx, which is height of story x. It is the story height, which is 20 feet here, and CD, it is the deflection amplification factor given in table 12.2-1, and it is given for us actually here, it is 5.5. In this case, if this theta, the stability coefficient, is larger than 0.1, then we are going to consider the P-delta effect. So, okay, now let's go to the third requirement, okay? Third requirement, which is check the P-delta requirements. So we're going to substitute in the previous equation, which is this equation, okay? We're going to substitute, and all the values, all the parameters are known for us. Now we are going to substitute in these, or in that equation, using the parameters. So first of all, section 12.87 requires that the total vertical load P1 at the first story considers the total load, which is sigma D, plus floor live load, which is sigma L, and snow load S above the first story, because these are considered the vertical loads. So we're having P1 equal to dead load plus live load plus snow load. Okay, so this is the loads. Take care. Sigma here means that all the floor above, and sigma here means that all floor above. But here there is no sigma because we have only snow at the roof, so it will be taken into consideration without sigma. Okay, these loads are unfactored. Again, take care. A common mistake that we use the factored load. It should not be used. Okay, it should not be used for determination of P delta effects. Consider it as service load as you are checking the serviceability limit state. Okay. In our case, there is no snow load, so snow load is 0 for the building site, and P1 is going to be only the summation of dead load and live load as given in the problem, and we are going to have it with this value, 12,493 kips. For story X1, we are going to substitute in the main stability coefficient equation, and we are going to put all the values here. P1, it is the summation here. Delta given for us, or we have calculated from the previous slide. V1, it is, take care, this is the base or the shear, story shear at this level. H, it's 20 feet multiplied by 12 in order to make conversion between F, the foot, and inches. CD given to be 5.5. Then when we substitute, we are going to find that our stability coefficient is 0.103, which is larger than 0.1. This means that P delta effects must be considered. We need to consider P delta effect in this case. Then let's check the theta maximum. Theta maximum for us. Theta maximum, we're going to use beta equal to 0.8, which is the demand to capacity ratio. It is 0.8 and it's given already. So we have theta max. So we have this theta maximum is going to be 0.5 over B, okay, over beta times CD, and beta it is 0.8 as you can see here. So in this case we are going to obtain it 0.1136. Our coefficient or theta is 0.103. This one is 0.113. We are less than this. So it is okay. What is the meaning of the maximum here, as we said before? What is the meaning of the maximum and minimum? Do you remember? In the previous video I said that the minimum is going to tell us that the P delta effect is insignificant, but it is existent. It is there. So who will take care of this value if our theta is 0.09, for example? No need to make any calculation, but it is existent here. So who is going to take care of it? It is the overstrength in the structure going to take care of it. But what about the maximum? What is the meaning of the maximum? The maximum is a threshold limit in order to limit or control the residual drift. Residual drift. What is the meaning of residual drift? You can check the previous video. I have explained it in detail. Okay, now let's go to our case. We are 0.103 less than the theta maximum, then we are okay. And in this case, the structure need to include P delta effect. There is a note here, if theta is larger than theta maximum, what should we do? The structure is potentially unstable and shall be redesigned. So if you have in your design, you found that your theta is larger than theta maximum, this means that you need to redesign your structure. Redesign. There is a possibility of instability of this structure under any seismic loadings. Okay. Now let's go to the requirement number 4, which is the final design story drift and story shear in first story. The final here, the word final means that we are going to include the augmentation of Pdelta. So Pdelta is going to be included in our case. When theta larger than 0.1, the initial design story drift and design story shear must be augmented, means that increased by the incremental factor A sub d related to Pdelta effects, unless incremental factor related to Pdelta effects on displacement is determined by rational analysis. Do you remember in the previous video we said that we have two approaches to take into consideration Pdelta? Two approaches. The first one is using AD, which is the augmentation factor here, or increasing the forces and the displacements using this augmentation factor. Or we can go to rational. Do you remember we said that rational analysis, and we said there are two types of rational analysis here. The first one is nonlinear static analysis or procedure, which is pushover, and the other one nonlinear dynamic procedure, which is nonlinear time history analysis. And we were discussing a little bit about NDP and what is the challenges here. But anyway, we have two ways. Now, in this example, we are not going to look to these two rational analysis. We are talking about approximate analysis now. So we are going to augment, or we are going to increase the forces and the displacements in our members and the story drifts by an augmentation factor. So this AD is going to be based on section 12.8.7 in the code. We're going to find that this factor is going to be 1 over 1 minus theta. Theta, it is the one that we have, the stability coefficient that we have already calculated in the previous slide. And this augmentation factor, we found it must be larger than 1. So it is going to be 1.115. So we are going to increase the forces and drifts, the design forces and the design drifts in our structure by 11.5%. The final design story drift in the first story is, so the final design story, we are now talking about the final design story, is going to be this AD times delta, which we already mentioned before, and we called it like initial design drift. So the final design drift is going to be 1.115 times 3.96, which is already we have calculated before, which is the initial drift. This gives us 4.415. So whenever that we are going to check now, we should use this value, the final design story, not the initial design story. Okay? And then the final design story shear is going to be A sub d times V sub 1, 1.15, it is increase of 11.5% times the initial story shear. Now we have another final design story shear. This one should be used for our design and the design checks. Okay. Now let's go to the next and the last part, which is related to the check for story drift compliance in the first story. So in order to find the allowable story drift, delta allowable, we need to go to table 12.12-1 in the code. I have already mentioned about it 2 videos before. So you are going to find that our case, it is special moment resisting frame and steel, so it is 0.02 of the height, of the total height. So our 0.02, and the height of the story is 20 feet times 12 for the conversion from foot to inch. So we have 4.8 inches. This is the allowable. However, delta 1 from the previous slide, we have delta 1 here. It was 4.415. So 4.415 less than the limit, which is 4.8. Then we are okay, which is our story drift is compliant with the code. There is only a small hint here that per table 12.12-1, there is a footnote. B says that delta allowable, this allowable, shall be divided by rho, which is the redundancy factor, in accordance with section 12.12.1.1. Okay, so take care only of this. It's a small hint, but it is subside track of our main topic. Anyway, the allowable should be compliant with the code requirements, okay, including table 12.12-1 and the section, this section 12.12.1.1. Okay, now let's have some comments on this. Okay, let's have some comments or commentary on our section or on our problem. According to section 12.87, P-delta effects on the design effects on the design story drift and design story shear are evaluated by the following procedure. He is talking here about the procedure of how we are doing the case. Actually, what the summary of this is related to that we are making augmentation. Do you remember that we put AD, and this AD we multiplied it by delta, right? And the same AD we multiplied it by V1, right? And then we got a new one, a new delta. Let's assume it's like, for example, like delta 1, and here this is going to be V, like, or let's assume this is delta prime, for example, and here this is V1 prime. But the problem is we need to recalculate these again. We need to go to another cycle, right, for P delta, because the values that we have used, the initial values, which were delta and V1, they were less than the final values. So we need to go to another cycle of augmentation. So the code is making it easy for us. Actually, we need to make this circle or this cycles, okay, repetition. So we need to make it like, it should be like this. One time we're going to use the delta itself, and after that we should add to it the delta augmented by using theta only, and then using theta squared, and then theta to the power 3, and so on. So if you are going to sum them up, you are going to find at the end it gives us AD equal to 1 over 1 minus theta. It is the series summation. So now this is simple. So do not think about the augmentation that you need to make another augmentation. No, AD already is including everything in it. Okay, so this is the summary of what he is talking about it. You can stop or pause the video here and you can read this passage, but you will understand it based on what I have explained here. Okay, so this is the first commentary. The second one, the final resulting story drift delta S prime equal AD times delta X needs to comply with the drift limitations of section 12.12. That's right. We have done this in the previous one. If you go back, yes, we were talking about this is the allowable, and our final should be less than the allowable. So we should, he wants to emphasize here that do not use the initial values anymore. Use the final values after the inclusion of P delta. And this is understood and it's okay. Third comment is in each story requiring consideration of P delta effects, the initial story shears are increased to the augmented shears. This is the final shears. The structural elements must be designed to resist the resulting final story shears, overturning moments, and element sections. And this is very true. In comment 2, he was talking about delta against delta allowable. Common 3, he is talking about V versus V allowable, which is the design for the resulting. This is the design. We want to check the overturning moments and element actions, shear axial forces, and bending moments and so on, against the final base shear after inclusion of the P delta. Another comment which is important, actually, this is an important comment, and you need to concentrate regarding this because many of us are using this. Commonly we use computer softwares to analyze the structures. We are not going to do it by ourselves, right? So in order to do the computer or making the analysis with the inclusion of P delta, it is very easy option for us on the computer softwares and these packages, right? So we include P delta. If you are going to do so, there is an important hint that you should keep in your mind, that the value theta that you are going to get after the inclusion of P delta in your software package analysis, the value theta from this computer analysis may be divided by 1 over theta. That's very important. So if your theta, for example, let's assume your theta is like 0.103 as our case, okay, then the real one that you should use in order to check for the theta maximum, it should be theta should equal to 0.103 over 1 plus theta, which is 0.103. It will be a little bit less than this, okay? If, for example, this would give us, let me like wipe away this to make it clearer. So if, let's assume that theta equals 2, we calculated from the computer analysis 0.2. This is coming from computer analysis, okay? So in this case, we should not use this 0.2 directly in order to check the maximum. We are going to say that our real theta is going to be 0.2 over 1 plus 0.2. Okay, this is whatever the value here, it is going to be 0.16, for example. Then this 0.16 should not exceed theta maximum. Okay, this is what this comment is telling us about. You can read it also and pause and read it. Okay, so please remember, this is an important issue that you should take care of whenever that you are making like analysis using software packages like SAP or STAT or MIDAS or any other software or OpenSeas. Okay. Okay, so this is the second, and the third, or maybe the last one. Yes, this is an important issue also. The last comment here is, as I said before, that P delta, it is related to the story. So whenever that we have P delta, and for this story, which is story 1, 2, 3, for example, so in this story, the augmented base shear, or V, is going to be like V prime, like this, okay? And here we have another V, which is not augmented, it is related to the second floor. It is V2, for example, and let's assume this V3 prime, and this is like V1, for example. Here this is V3 or V prime 3. This means that we included P delta in the calculation of this base shear. Actually, it should be V3 only, without V prime. It is like a little bit higher or larger than V3. But the problem is, this V3 prime, it is going to add some additional moments on the lower floors, right? On V2 and V1. That's right, because whenever that we increase, let's assume that V3, which is without P delta, it was 100 kilonewton. However, that V3 prime with the inclusion of P delta, it was 120, for example, kilonewton. Actually, this building, it will have 120 applied here. This means that there is 20 kilonewton additional loading has been added to the third floor, and it will affect the displacement at the second floor and the displacement at the first floor, right? So that's the case that what we want. And actually the problem will be complicated if we have another top floors having some P delta and other floors does not have the P delta. Okay, so what should we do here? The problem here can be solved like this. The final drifts should be found by a new analysis with the added lateral loads equal to AD minus 1 times Vx. This is with the inclusion of the P delta. Along with, this means that plus another analysis, which is initial lateral loads on the frame. So we are going to have two sets of frames. Okay? Like this, for example, and another frame. Okay, like this. Here, this is the additional value coming from P delta, the small ones. For example, here, here. If I'm going to talk about V3, here it was the additional one here was 20. Here the additional one, the additional due to P delta only, okay, without the initial value of the storage shear. Let's assume it was 10. Here, for example, there was no P delta, so it was 0 here. We are going to run the analysis and we are going to obtain the delta here. And then we're going to set here the initial V or the storage shears, the initial one, the original ones, okay, without P delta. And then sum them up. The values, the drifts that is going to come, we're talking about the drifts, okay, the final drifts, okay, is going to be the final drifts for us. Okay, similar also are going to make it for the base or the shears on the columns and the straining actions on the girders and so on. They are going to be affected by the top stories augmented shears. So this would be done by doing like two sets of analysis and summing them up. Okay, the first one is AD minus 1, which is this AD minus 1. It means only the additional part of P delta without the initial part. Okay, and another one is the initial lateral loads only, which is Vx. Okay, that's it for this comment, and I think it's an important comment for us. Okay, the last thing here is related to the value of beta, how we can obtain the value of beta, may be taken as the highest demand to capacity ratio. Alternatively, we are allowed to use plastic analysis in order to obtain this beta. Actually, this beta, as I said, commonly you can obtain it, you can put it like 0.9 or 0.8, but if you can do it, there is a simple way for moment resisting frame, which is already given in ASCE. I'm going to maybe explain about it in the next video, how to obtain this beta based on this this method. It's only for moment resisting frame, so we cannot apply it for like brazed frame or shear walls. We cannot do it. And the plastic analysis can be used in this case if you want to be sure how much exactly the capacity or the demand to capacity ratio, in order to apply it in equation 12.8-17. Okay, this is the end of this example. There is another example for multi-story. I'm going to explain about it maybe in another video. Okay, thank you very much, and see you in a next video.